So let us go ahead with the today's agenda. Today is a day 4 of this particular course. As we know, this course duration is will be like 10 days, okay, 3 hours each, right? So this will be a day 4, and in this particular day we'll be talking about classification algorithms. Okay, what are the different classification algorithms we have, why to use classification algorithm. Then we'll be talking about the different classification algorithms. We will be starting with the logistic regression. Then we will be talking about the decision trees and random forest. Also, we also talk about the model evaluation matrices like the confusion matrices, classification report, as well as the ROC curve. Let's go ahead with the classification algorithm. As you know, guys, this course will be a around 80% practicals and 20% only theoretical. So you can be able to hands on with the different algorithms of the machine learning, as well as the basics of Python, basics of R, MySQL, Tableau, and Python, uh, Power BI, right? So see, if we're talking about the machine learning, there are three main categories, right? First one, supervised learning. Then second one is unsupervised learning, and third one is going to be the reinforcement learning. And fourth one, we have a semi-supervised learning. So this is going to be hybrid type, right? Okay. So guys, for this particular session, we will be talking about the classification algorithm. As we know, there are three main types of the machine learning. First one is supervised. So in the supervised learning, we have the two different types, or you can solve the problem of in the supervised learning. And what are those problem? First one is regression, second one is classification. So as we know, we saw yesterday about the regression. So in the regression, okay, we are trying to build the model which can predict a numerical values, okay, like a the prediction of sales, right? Or a prediction of any price. We can say prediction of gold, prediction of temperature, prediction of you know we can talk about like a share market and all. Yeah, prediction of shares and all, right? So these are the different types we have in the reinforcement, sorry, in the supervised learning, we can say classification algorithms. Okay, if we're talking about okay this particular thing, okay, the classification algorithm. So here you can see that we are building the model which can predict a class. If we're talking about the the class, so we can say that the class is having the the category, different types of categories. Okay, let's say yes no category is there, then true false category is there. Like if we're talking about the another the example of the class, so we can say that you know the spam emails. In the emails, how many categories are there? The primary email, social email, okay. Then we have the you know the some kind of spam emails, okay, right? So you will find that the multiple categories in the email as well, right? So here as well, yes, in the gender, male and female categories, two categories are there which are main. Okay, so these are the things. So basically, if you're talking about the difference between the the classification and regression, so here, as you know, suppose if we have the data, so here you can see that our in the regression, our main goal is to predict a numerical values for our upcoming data set, or for just predict the future values, right? So here you can see that we have the data points with the we have the only data points, and here you can see that the main goal is to find out our upcoming data points, right? Let's say if we have the sales data, okay, till the March month, okay, and we wanted to predict the the sales of upcoming month, which is April, right? So by using previous months, we are trying to build the model which can predict the sales of upcoming month, right? So that we saw in the regression. Now what is in classification? So in the classification, you will see that, okay, there is binary class classification problem is there, there is multi-class classification problem. So if you see this particular plot, so in this particular plot, okay, if you see this particular plot, so here you can see that the two different colors in the data points, first one is red, second one is sorry, first one is green, second one is blue, right? So here you can see that there are two different colors, which means that there are two different classes in my data set. Yes, so I have to classify these two classes by using some mapping in between that. Okay, there is something, okay, or some conditions are there, or some mathematical concept is there. With the help of that, we can be able to classify that data into the two groups, okay, or into the two different classes, let's say the green class or let's say the blue class, right? So here you can see that, okay, we just build the model of classification, okay, like just don't imagine this thing in the not just the the two dimension. If we're talking about the let's say we have the data of the 10 columns, let's say at least 10 column we have. So we can't imagine the 10 dimension data, right? We up to 3 dimension of the data we can able to visualize, but we can't visualize the 10 dimension data, right? So here, okay, just to understand the concept of classification, okay, here this plot, from this plot you will understand what is classification. So here in the real life you will find that the few data points, okay, of the blues as well as the few only from the green also are here in this particular blue region, let's say. Also here you will find that the most of the data points are nothing but the green, and here also you will find that the most of the blue data points, okay, which means that, okay, like there is like many times, okay, when you are dealing with real time data, so at that time you will have to you know just understand that you will very rarely get the 100% accuracy, right? So that is the thing, okay. So these points, this this, out of this most of the green data points, you will find that the few blue data points, so those are nothing but your misclassification, right? In the same way here you will find that the green data points, which are few data points in the blue region, or most of the blue data points, right? So guys, let's understand about the classification algorithm in more detail. So that's why we will go further and we'll try to understand the different algorithms of classification, right? Okay, so let us talk about the linear regression versus logistic regression. Okay, so guys, as you know, what is linear regression? So here you will see that, okay, this right plot is going to be, let's say, linear regression, right? So here you can see that our data is different now. Our data is different, right? So this is my data. So basically you have, let's say, X and Y data. You have the two classes, right? So but your label is nothing but your Y data, right? As we discussed yesterday, or let me show you on the whiteboard so you will understand this thing. Now guys, as you know, if you are talking about the regression problem, so here you will see that the data set like this, either this or in any other, this is the upper trend data set that I am drawing. Okay, you may go, you may get a data set in the downward trend or the the non-linear pattern as well. So let's say this is my, this is my regression line and this is my data, right? And I have created a, regression line which is going in this particular in between these data points, which is exactly middle. Okay, now this is going to be the x coordinate, this is going to be the y coordinate, right? Okay, data, and this is how I build the model of the regression. Now let us see if we got the data like this. Okay, if we got the data like this, okay, this is my x coordinate, this is my what y coordinate. Now you will see that, okay, you will get the data in the range of, let's say, starting from 0 to, let's say, 100. But here your target variable is not the continuous one, it is going to be the, let's say, discrete one. Okay, like let's say, let me assume this is, okay, here is my 0, okay, to show you, just to show you. Okay, and this is one value. Okay, and now we got the data like this, few values are over here in this particular region and few values are over here. Okay, as we know, we got the data like this, x values which are, okay, let's say 32, 22, okay, 41, 56, okay, then 78, okay, in between 0 to 100, right? And your y data is like this, 0 1 1 0 0, right? So which means that if you plotted that data, so your data is not visually correct, you can say. So you can simply say, okay, if we write this particular data, so okay, this is my data over here in the regression type of problem. So again the same, okay, let's say 11 42, okay, then 53, I would say, then 24, like this. Okay, then 66, like this. And here you will find that the same kind of thing. Okay, 21 32, okay, 61, right? 25, okay, 78, like this. Okay, so here you will find that, okay, my y data is also somewhat continuous, you can say, right? So okay, and this also is continuous manner. Okay, let's say this is my the, let's say, age, okay, column, and this is going to be the, let's say, any column. uh let's say the column is going to be the height, let's say. Okay, height column is there. Okay, so this is my age and this is my height, both are continuous one. So you will see the data like this, right? Now if we're talking about the classification one, you got the data like this, x data, right? The y data, okay, this is your y data, right? But here you will find that in your y data looks like this, 0 and 1 format only. There are only two classes, 0 and 1. Okay, so apparently, okay, after plotting scatter plot, so you will find that your data looks like this. Okay, few values over here and few values are over here. Now if you plot, okay, if you plotted the regression line, so you will see that your line looks like this, right? Your line looks like this. Okay, which is not the perfect equation for this particular problem, for this particular data, right? So for that you will have some kind of data or some kind of model like this, right? So you will have the data like this. Let me show you again over here. Okay, you want the model like this. Okay, so here in the PPT, if you okay, if you see, so here I'm trying to, okay, show you the same thing, right? I'm trying to show you the same thing. Understood? Okay, this is my regression problem. If we are using the regression on a, linear regression for this particular kind of data, so this won't work. So at that time you will have to use the logistic regression, right? So in the logistic regression, how we just created this particular line, okay, what are the different transformation we applied on this particular linear line, so we just able to convert this line into the S-shaped curve. This is somewhat like S-shaped curve, isn't it? Right? So this is my logistic regression, right? So in the name itself there is logistic, which means that I have used logist function over there, right? I have used logit function over there, right? So okay, let us understand what is exactly logistic regression is in the, in the deep way, so you can be able to understand this thing, right? So this is going to be my sigmoid function. And what is this, guys? Okay, this is over here you can put your regression line, our regression function. Let's say your function of x, which means that y equal to beta naught plus beta 1 x. Okay, this is the just the simple linear regression I'm talking about. If you're talking about the multiple linear regression, so you can add the terms like this, beta 2 x2 up to so on beta n xn, right? So this is nothing but the function of x, isn't it? Is this a function of x? This is a linear combination of the your coefficients and your columns, the features which are there in your data. Okay, so that is nothing but it is a function of x, f of x, right? So you can use these over here. So 1.1 plus e raised to minus f of x. So this is going to be your sigmoid function. Okay, let's say you have the x like this. Okay, the 1, 2, 3, 4, 5, 6, so on. Okay, and you are using this sigmoid function, right? Sigmoid function is like this. Sigma of x is going to be the, you can use this formula, you can use this formula, you will get the values, some values, right? You will get some values and the plot for these values will look like this. The plot for this particular column, right? So that is the power of sigmoid function. Okay, now one more thing here over here is, okay, this sigmoid function is very much important. Okay, why I wrote this particular sigmoid function is because if you see that in our in our previous problem, the values for y are this 0 and 1, right? There are two values, okay, which are nothing but the 0 and 1. So if you wanted to find the probability of 1 and probability of 0, so at that time this probability has nothing but the, you can calculate by using the p of x, okay, which is equal to 1 divided by 1 plus e raised to minus f of x. Okay, and this will give you the, probability of class 1, right? And if, okay, and in short, okay, this is a probability of x. In short, I will write, okay, like this, x equal to 1, because here you will find this, but in the continuous manner you can't write this, okay, because it's a equal to sign, and in the continuous probability you will find that if you write this, so which means that its value will be 0. Okay, that's why I'm ignoring this thing. So that's why I have just written over this like this, right? So just, forget about this, because okay, this is not possible to write, okay, the write the probability in the continuous manner like this. Okay, so here you can see that the 1 minus probability of x is going to be the probability of So you can simply use this. And what is this guys over here? This is just the simple linear regression function. Okay, let's say if I have, okay, let's say this is my problem, y and x problem we have. So I can simply write the model for this is going to be the beta naught plus beta 1, okay, x. This is simplest model I can say. Okay, I can use this particular model. Okay, I'll write this particular model over here and we'll get the model like this, okay, which is the S-shaped curve, right? So let's go over here, okay, and here you can see that, okay, now we got the values, okay, in terms of you will definitely get the values in terms of y, either y equal to 0 or y equal to 1, right? So this is the thing over here. So that is what I am trying to, show you over here, okay, either in this particular plots or in the whiteboard as well. Okay, if you see over here, okay, so here you can see that, okay, this is my linear regression. Okay, this is my linear regression. So if you see over here is, okay, if you see over here is, okay, the error you see, okay, is very less. Error is nothing but the distance between your original data points and your regression line, your predicted data points. But if you see over here is the distance now, okay, is very less as compared to this distance. If you plot the regression line over here, so you will find that for this particular data points, distance will be very high. Distance will be very high. So it can't predict the right output, right? It can't predict the right output because the aim of the regression model is to predict the continuous values or the continuous data. Okay, so you will find that it will definitely predict the values from, okay, if your data looks like this, so it will be able to predict the values from here, okay, like this. But if let's say if you build the regression model over here for this particular data, so you will get the values, let's say, okay, you will, let's say you will get the values from here. Okay, so you will find that the value of y is 1, but you will get the value from here of here, okay, which is not the correct value because the y values, okay, are just the two values, like the 0 and 1. Only two classes are there for y, right? So that is the problem with the regression model over here. Okay, that's why you will have to apply the sigmoid function over here and it can be able to predict the values either 0 and 1. Okay, and it can predict the values in the form of probability, in the form of probability. Okay, not the exact value, not 1 and not 0. So now let us go ahead and let's do some practical so you will understand in more details, right? Let's do some practical. Okay, I have shared you the the data, okay, which we will be using for this, but I guess not for the logistic regression. Okay, we will be using this particular data for the decision tree and the random forest. Okay, we will be using, okay, we just creating a dummy data for the logistic regression, right? So guys, let's create the dummy data. Okay, see guys, okay, uh you know when we are dealing with this thing, okay, like when we are dealing with this thing, okay, why we, okay, let me ask you a question. Why we are creating the model? Why we are creating the model? Our aim is to predict the value, right? Either value in the form of numeric, okay, which means the continuous data, okay, either or in the form of classes, 0 1 class, right? So this is our main objective to build the model, right? So if our data is continuous, I'm talking about y, okay, if okay, I'm talking about y data, which means our main target column that we want to build the model, okay, which can predict our target column. Okay, so if we're talking about our y data, if our y data is continuous, right, if our y data is continuous, so we'll have to go with the regression algorithms, right? We'll have to go with the regression algorithms, right? And if your data, if your target data is the labels or the class data, so which means that only two values are there, only three values are there, only four values are there, which means that that data is the label data. Okay, that data is nothing but the label data. That's why you will have to use the classification algorithms, right? So here I'm talking about the error, because if you are using the regression methods or regression algorithm for the classified data, for the label data in the form of, discrete, your target is discrete, so it's not possible. At that time you will get the, very high error, right? So if you are using, okay, the regression over here, this is not suitable. If you are using the any other classification model, that will be suitable over here, right? So that is the thing. Okay, now guys, let us go ahead and talk about the logistic regression. So here I just rename this particular notebook as the classification algorithms, right? Classification algorithms. Okay, so as we know, first classification algorithm we will see, which is nothing but logistic regression. Okay, so guys, as we know, we have to import few libraries, right? So what are those libraries? As we know, first we'll start with the pandas as PD. Not understood your question. Why? What do you want to say? How do we get the title in the notebook? Okay, here you will find the, the, like, acha, you wanted, okay, you want this kind of title. Okay, if you want this kind of title, you will have to convert your coding cell from the markdown cell, right? This is my coding cell. Okay, I just converted this coding cell in the markdown cell and I got the title, right? So this is how you can create the title. Okay, here what we are doing is we are, okay, importing the libraries, okay, which are important for our analysis, right? Then second we have the import numpy. It's not the comment, it's the code. So I'll have to go with the directly import numpy as np, right? Third library is going to be the import matplotlib dot pyplot as plt, right? And what will be the fourth one? For creating a classification model, we will have to import the fourth library. And in Python, the most important library for the machine learning algorithms, which are nothing but the sklearn library. Okay, we will be using a stats model library for regression, okay, not for logistic regression. Yes, there is some confusion because of the over the name over here, which is regression, but you will find that logistic regression is the only regression algorithm, okay, which we will be using for the classification. Okay, this is not the, we can't solve the problem of regression by using logistic regression. Logistic regression is solving the problem of classification. Okay, and this is the only model which we can, use for the, the classification. It can do only one thing, classification, not the regression. We have a lot of multiple models, okay, which we can use it for the, you know the classification as well as the regression one. Okay, as we will talk about those as well. like the decision tree and the random forest. We will be, okay, understanding those model in the same session. Okay.